This video is going to be about motion diagrams used in physics problems. Motion diagrams are used to model the motion of an object. Let's look at the parts of a motion diagram. Motion diagrams have three parts. First, the axis. Next, the clock readings. And lastly, the vectors. Let's look at how a typical motion diagram looks like. First, let's draw the axis. This is going to be the position axis, which we will denote with an X. Arrows, like the one over here, are used to indicate the positive direction of motion. And in physics, we don't put the arrows on both ends. We only put it on one end in the direction of positive motion. So that's going to be towards the right in our case. This is always based on point of view. There is no right or wrong positive direction of motion. You need to indicate it, which is why it's very important to include this arrow, because in physics, we cannot assume that positive is in the right direction. We say that it's in the right direction in this problem. We could also put it this way, but we would have to indicate that. And then our next part is going to be clock readings. So clock readings are going to be in the form of dots. So let's place some clock readings down here. So right now, I've got 6 clock readings on here, which we will denote as X1, X2, X3, X4, X5, and X6. In motion diagrams, we don't normally denote it like this, like with X1, X2, and all, but I'm just doing it right now to conceptualize everything. So, a very important thing about the clock readings in motion diagrams is that they are by the same time interval. This is extremely important, and this is the premise of motion diagrams, because we need to know that the same amount of time elapsed between these two positions and between these two positions. So what are the implications of that? Well, that means that in 3 seconds over here, our object traveled this far. But in 3 seconds towards the end of the motion, our object only traveled this much. So what we can see is as the intervals progress in this motion diagram, the displacement is decreasing. And that means that the object is slowing down. Let's look at some scenarios where we can use motion diagrams to describe the motion of an object. Our first scenario is where a car is moving right at constant velocity. So let's draw our first part of the motion diagram. Let's include our axis. Let's indicate the positive direction of motion. This is the position axis. And now let's put our clock readings. So we have 3 things going on here. We have right, constant, and velocity. Let's address all of these in turn. So first, let's get our clock readings down, and let's introduce constant. Let's put that on our motion diagram. So constant means that the clock readings need to be equally spaced apart, because as the intervals progress, the car is getting displaced the same amount in the same amount of time. So now let's think of velocity. For velocity, we need vectors. We need our arrows. Because over here, this is speed. Speed is a scalar. Velocity is a vector. And when we need to talk about vectors, we need arrows. We need to indicate that direction of motion. That is our third part of the motion diagram. Vectors. Because without this, we're just talking about speed. But when we're talking about velocity, we need those arrows. So we're going to add that. But where should our arrowhead be? This car is moving right. This is in the positive direction of motion. So we're going to put our arrowhead pointing towards the right. And now, this is our motion diagram for the first scenario. let's look at our second scenario where the car is moving right and speeding up. Now, over here, when the displacement decreases over time, the car is slowing down. So, it only makes sense that when the displacement is increasing over time, the car speeds up. So that's what we're going to do. We are going to make the displacement increase over time. And, of course, the car is moving right, and we are going to add our vectors. And now, for our next example, the car is again moving right. For our next example, the car is again moving right and slowing down. So, here we did speeding up. Now we're going to do slowing down. So, that's going to be the same example over here. It's going to be when the displacement between intervals is decreasing as the intervals progress. And still our car is moving right. Now, for our final example, now the car is moving left at a constant velocity. So, left. Our positive direction of motion is in the right. So, what we need to do is we can think of this as where we start. This is technically 0. We're not starting from here anymore because now we need to move to the left, and the right is our positive direction of motion. So we need to move opposite to that. So, constant velocity, we need to make sure our clock readings are evenly spaced. And now we are going to add our vectors. So, our vectors are going to be pointing towards the left, opposite the positive direction of motion. That's all for this video. Thank you for watching and good luck studying.